Hey folks, welcome to another Triple T Thursday. For those just joining us, that's tools, tips, and talk, where we'll discuss info for the knife maker. In today's episode, we're going to continue our Damascus series and make what I think is one of the most spectacular Damascus patterns, the feather pattern. And not only are we going to make a feather pattern, we're going to make a special variation of that one called the River of Fire. So let's go down to the table and take a look. So let's talk about feather Damascus and the basics. So the basics of this pattern, you're going to take a billet of alternating 15 and 20 and whatever, 1080. You're going to restack it, and eventually you're going to get a bar, okay, with a lot of layers like this. Okay, then you're going to cut it like this into these bars. Then you're going to stack it up. Okay, so it would be like this. You're going to stack them up tall, and you're going to drive a wedge through it. Could be an axe, something like that, and you're basically going to hot cut it. Okay, what that's going to do is all the layers will then get dragged down by the axe, and they'll start to look like this. Okay, and then you'll obviously have two halves. Then you're going to forge it back together, and these things will connect, and it will look like a feather. So that's the most basic feather pattern. Let's talk about a variation of the feather. So I'll put a picture here of a knife that I did with that previous feather pattern, and you can see that it's kind of basic. It doesn't really have a lot of movement in the pattern, so to speak. So let's talk about the next variation. So instead of just straight layers, we're going to do C's. Okay, so this is our billet, and we're going to restack those so that we get crushed W's. We've done this in other patterns. So typically you're going to get a restack of at least 4 and then restack it again. Basically you're going to have tiny, tiny W's. And then you're going to slice that up just like we did before in a bar. So all your W's are running this way, right? And then you're going to do this, okay? And drive the wedge down through it. Then you'll get a pattern that looks like this. And you can see the feather is much more impressive, it just looks more like a feather. So it's much better to do the crushed W's before you split the feather. We're going to be doing a bit of a variation on both of these. So the difference of what I'm going to do here, instead of this pattern where you would cut them up here and then drive the wedge this way, what I'm going to do is forge the billet in a long bar like this, cut them like this, stack them this way, and cut this way. So the theory is that because the end billet is going to be pretty thick because I'm doing a spear. Okay, so this is the cross section. So this would be here. I'm going to be doing pretty steep bevels on this spear. So I want to reveal this pattern by doing this bevel. That's the theory. We'll see how it turns out. But let's get to forging.
I needed a lot of steel for this project, so I'm starting with 6-inch pieces instead of 4. Now it's time to get them welded up. You'll notice I'm also putting a strip down the center because they're such large pieces. After a little dip in kerosene, in the forge they go. You'll notice I ground off the weld on the side here a little bit, just so it didn't get pressed in. Just like usual, spending 3 heats just setting the weld. Our billet is starting out like the graphic in the corner. Now I'm just going to the grinder and I'm grinding out all of that weld. I do not want that in my final billet, so it's best to get it out early. Now we're going to press in the corners and we'll get the graphic in the corner. That's going to be our first step towards crushed W's. Now we're going to press this bar flat, and that's going to give us our C's. Now you see why I refer to crushed W's as one of those mother patterns. A lot of patterns are based on that pattern. Now I'm straightening up this billet, getting the corners all nice and square, getting ready for the restack. Hey folks, wanted to pause this video here and talk about this new Vevor welder that they sent me. This is a TIG welder, and as you guys know, I mentioned TIG welding before. And for those that aren't super up to speed on the different welding processes, I wanted to go over why it's important or very useful to have a TIG welder when you're doing Damascus. And since this is a Damascus series, I thought this would be an excellent time to go through TIG welding, why you want it, what features that I was interested in this machine and that my other machine doesn't have. So let's go down here and talk about TIG welding a little bit. Well, folks, here's my current machine. This is a 3-process machine, meaning it will do MIG, TIG, and stick welding. What you see me use this for most is MIG welding. And just for folks, the way MIG works is that, all of this is considered arc welding. You're creating an electric arc between your workpiece and the electrode here. And the way MIG works is there's wire. This is consumable wire that's in the machine that goes through here, and you're feeding wire towards the workpiece, and that's making it, creating the arc, melting the wire, more wire comes out. The problem when it comes to Damascus is that this is mild wire, and you're melting mild steel into the workpiece, which of course, if you're working on hardened steel, that's not always nice. That's why we talk about when I'm welding the end of a stack, I want to do it so that I'm going to end up cutting it off. And so that's a bit of a pain sometimes to make sure you get all the mild MIG weld out. So that's why it's nice to be able to TIG weld. And TIG weld, with TIG welding, you create an arc, and then you can use filler wire if you're actually doing a welding process. But the TIG itself doesn't introduce wire. You can TIG without wire, and that's considered fusing. You're fusing those two metals together. You're just melting those metals together. So you're not introducing any of that mild steel. So this does TIG, but the way it does TIG is a little different than this Vevor one, and it's a little more simple, archaic. So I'm going to go into a little more detail, but first I want to explain what TIG is, and then you'll explain why it's important. So let's talk about TIG. First, let's define it. TIG. TIG stands for tungsten inert gas. And that's because this electrode here is made out of tungsten. And tungsten has a melting point of, I think it's around 4,000 plus degrees. It's very, very high compared to steel. So this electrode can be heated up really, really high. Okay, so generally what we're doing is we're going to create an arc between the workpiece, let's just say this is our workpiece, and the electrode. Okay, so that arc is going to be super hot. Okay, as you travel across the workpiece, it basically just has a cone of, and I'll show a picture in the corner here, it'll have a cone that you're just going to move across the workpiece, and it will produce very high temperatures. So, you know, if you would just produce very high temperatures without any shielding gas, it would just create all kinds of pits and holes as it oxidizes. So what you do here is, why it's called inert gas, is this thing is set up with a hose here, and it's connected to an argon bottle. So 100% argon, at least for most uses. And this little knob is just going to turn on the argon flow. I don't actually have this one hooked up to a bottle, but that's what would happen. And that argon gas spraying on your workpiece is going to protect it from oxidizing. So that's an important aspect. So on this one, the gas is always flowing while this knob is open. Okay, and you would just move across the workpiece. The problem, this is my old one, the problem with this one is that the way it starts. To start the arc, okay, kind of like a stick weld, you have to touch the electrode to the workpiece and lift it off. Okay, so that will start the arc. What the problem is, that kind of affects it kind of burns out your electrode a little bit because you are touching it to the workpiece. And it's the biggest pain is that when you're done, to end the arc, you basically have to lift away far enough that the arc stops. But the problem is you're also lifting the gas away from your workpiece. So then the end of your weld, you get a little hole or something because you're removing the argon. So not so good. It's kind of a pain in the butt to start, and then finishing, you get a little smudge. So, you know, it's not very nice. Now, if we move to the new one, the one from Vevor, you will notice some differences here. So this one has a button here. Okay, and I'll talk about foot pedals, but the difference here is this button starts what's called a high frequency start. So you can actually hold the electrode a little bit away, like the normal, whatever it is, 1/8 of an inch away from your piece, press the button. That will initiate the high frequency start. You'll hear kind of a buzz. It will start the arc, so you never had to touch the workpiece. And as soon as you press the button, even before the arc starts, it starts the gas flow. So now you can just hold the button, move across your workpiece, let go of the button. Okay, that'll end the arc immediately, but the gas will still flow for a few seconds. So then you don't have to pull this away from your workpiece to end the arc. So the high frequency start is exactly what I wanted out of a machine. So that's what's really cool about this Vevor machine, is this high frequency start. If you're an experienced TIG welder, you probably have a much higher end machine that has a foot pedal. For those novices here, the reason a foot pedal is nice is because you can vary the voltage by how far down you press the foot pedal. For beginners, they don't actually advise you even have a variable voltage foot pedal because it's just one more thing to worry about. For me, I'm usually fusing. I actually want it to be simple with just this, so it works perfectly for me. So I've done a lot of talking. Let's give this a little shot here and see what it's like. So let's take a look at this machine. This is where you would connect your TIG. So this is the TIG torch. This is the high frequency start, and the gas is coming in through here as well. The gas plugs in the back. We'll take a look at that in a minute.
This is your ground here for this. I think this one also does stick welding, so it's got a port here if you want to do stick welding and flip these. It's got a little switch at the back to turn this on. I don't have it plugged in at the moment. It's simply just got a dial for your amps and how many amps you want feeding to the welder. Okay, it's as simple as that. And there's a 2T, 4T. I won't get into too much of that, but it'll have a reading of the amps here. And whether you're TIG or stick. Flipping it around, it's just got an input for the gas. The only thing I didn't like about this welder, it just gave you this kind of cheap hose. I expected this thing in the back to be an actual connector and not a nipple for a hose. So I actually had to go out and buy a new connector that would go into my reg, because you need to feed this into your reg on your argon bottle. So I wasn't thrilled that they just gave you a hose, but I guess it's fine. It only cost me $10 for the fittings. On-off switch. So I'm gonna set this one up. I'll set it at about 110 amps, and we're just gonna fuse a little bit on this steel. Let's give it a shot. So I've got the machine running. You can hear it humming in the background. I've got it set at about 105 amps. Now, I'm doing this on a really thick piece of steel. This is like 3/8 thick at least. So 105 amps is not very much, but that's because I just want to be fusing. And you can see I've done a few test pieces here. I'm just going to put a few lines here just to show you how it starts and what it looks like. I've got my gas turned on, my hood in place. Let's give it a shot. That's really cool. Super easy to use. I lifted the torch away a little bit far here. I got a little anxious. You'll notice the first one is a lot better, no holes. Let's do another one here. I'll go down and back. So I'm really impressed. Easy starts, easy stops. Fusing really well. So for a basic TIG torch, I think this is great. This whole machine with the high frequency start and the button, I think is around the
$200.
I'll put the exact price down, but it's a really great deal. Like all the Vevor products that I've seen, you really get the value for what you're paying. I'm really impressed. And I would definitely give it an honest review. I don't like the hose. I wish they would have supplied fittings for the hose. But otherwise, I think it's a really good deal. If you're looking for a TIG torch and you want a high frequency start, consider the Vevor. So there'll be links down in the description. Go check this out. I want to thank Vevor for sending me that TIG welder. I'm going to put it to good use. I also want to thank our sponsor, Maritime Knife Supplies. For all your knife making needs, go see them. Also, if you live in the U.S. Northeast, Maritime Knife Supply is providing a scholarship to the New England School of Metalwork. So if you live in that area or you want to attend the New England School of Metalwork, go check that out. You might qualify for that scholarship.
And here it goes, restacked back in the forge. Now with the restack, it looks like the graphic in the corner. And now we're just going to draw this out just like we did before. We're going to get a nice long bar and we're going to restack it again. The trickiest part of the feather, of course, is yet to come. Not only splitting it, but putting it back together and then drawing it out is always a challenge. So we're going to talk a lot about those steps later on. Well, folks, I lost a bit of footage of a restack and drawing that bar out lengthwise. So you get the idea. It was restacked, stretched out, and now we're going to go cut it up. So here we are so far. I've ground the bar nice and flat on the surface grinder. Now I've cut it into equal pieces and numbered those pieces, 1 through 8. Okay, now we're just going to do this to the pieces and then stack them up. This will ensure that all of our ends meet up correctly. We're going to forge weld this all together, then split it down the center. This is the first place that can go wrong with a feather. If you cut these pieces too narrow, when you go to press them and forge weld them together, they'll tend to bow a little bit, and that's a big problem. Make sure they're at least 1 inch wide. Before I do the split, I hit it on the sides to make sure the billet is nice and straight. I don't want any bowing when I go to do the split. So here goes the split. This one didn't go exactly as planned. I got it a little off center, and problems ensue after that trying to fix it. I don't know if you saw that, but I actually bent the wedge trying to fix this. So I had to take that out, bend it straight. This was a big problem. I finally just went with it, just went nice and slow. It's still off-centered a little bit, but I'll fix that later. There, finally, we have success. I've split it into 2. Now I'm taking each of the halves and just pressing them straight and kind of making them the same size. I'm going to end up grinding off a little bit on the one that was bigger. Okay, so here we are so far. We split the feather. I've ground the sides. This one was a little thicker this way, so I ended up pressing it and just grinding it a bit to get them all the same. And then I've taken a bunch of 1080, this was just happened to be the thickest 1080 that I had, and I've stacked this up. And you'll see in the next step what I'm going to do here. So now we're going to forge weld this all together this way. I added the 1080 here because I'm doing this river of fire, but this really was an aha moment for me. Because the hardest part of a feather pattern is when you go to draw out the feather into a long billet. The ends always want to separate on you. But now, with the steel on either side, that doesn't happen. So this right here is a really important discovery. From now on, when I do feather pattern, even if I'm not doing the river of fire, I'm always going to put a little bit of steel on either side. And that'll protect the ends, the edges of the feather when you draw it out. And it'll prevent them from splitting. So what is this river of fire I'm talking about? It's really just the wavy feather, meaning the feather pattern kind of meanders back and forth like a river. You'll see what I mean. In order to make that feather meander and wave back and forth, we're going to cut scallops on the side of the billet, opposing each other on either side. That way when we press it, it's going to push that feather pattern into the scallop, and it's going to make it curve back and forth.
Well, folks, obviously I've done a bunch of forging on this. It is now in spear shape, so stay tuned for this build video to see this guy finished. But I wanted to give you guys a shot of the Damascus. And you can see the feather is nice and curvy all the way down, and it goes right to a point here, which is very cool. There's not much action in the feather, but my hope is when I grind the bevels, you're going to see much more action in this feather. That's why I did it the other way. So yeah, but there you go. That is how you do a feather pattern and how you do the River of Fire. I hope you guys got something out of today's episode on feather Damascus and the different variations. I love the way the River of Fire turned out, and I think it's going to look really cool in that spear. You're going to see the bevels. I'll make you wait till the spear build in probably a couple of weeks to see what the final pattern turns out to be. So stay tuned for that build. Thanks for joining me, folks. We'll see you on the next one.